Welcome to example number 9. In this example, we're asked to find the unknown quantity. So for example, in parts A, B, C, and D, we're asked to find the direction of the magnetic force. Before I proceed into that, let's just do a quick review of the right-hand rule. So remember that our fingers represent the direction of the magnetic field, the thumb is the direction of the electrical current, and our palm acts in the direction of the force. So in example 1a, if you look at our diagram here, in the bottom right corner you can see my hand here. Our fingers are pointing to the right, and the thumb must be pointing in such a way that it's pointing upper right. So for this to occur, my hand will have to be positioned this way, with my fingers to the right, my thumb pointing partly upwards, and my palm of my hand will be facing into the screen. So therefore, we're just going to draw a X in here, and that's the direction of our force. So magnetic force is into the page. All right, in B part, we have a current that is going to the right and a magnetic field to the right. But if you notice, they're both to the right. That means that the angle between the direction of the current and the magnetic field is 0 degrees. And if we were to use the formula FB equals I LB sine of theta, and in this case our angle is 0 degrees, and sine of 0 degrees is 0, so there would be no magnetic force. So whenever the current is in the same direction as the magnetic field, there is no magnetic force. Okay, moving on to part C now, we have a field that is going up and our current going to the right. And so in this case our palm will be facing towards you, and so our magnetic force is out of the screen, or out of the page. So this is out of page or screen. All right, in part D, we have now an X here, which means that the current is going into the screen and our field lines are going up. So for this to occur with your hand, you have to put your hand, your thumb, into the screen and your fingers upwards, and you'll notice that your palm will be facing to the right side of the screen. So this wire will be deflected to the right. That's our magnetic force, FB, to the right of the screen. Okay, now moving on to the bottom half of this problem. It's a little bit different now. So in this case, we're going to be looking at a U-shaped horseshoe magnet, and you have the North Pole shown and the South Pole, and then this is a wire that is really just coming straight out or straight in, depending on the situation. So if we look at this, we're not shown the force. But you are shown, by the way, there's a North and a South Pole. So hopefully you'll realize that our magnetic field goes from the North Pole to the South Pole. So we have field lines that are going to the left of your screen, and then we have a current that is coming out towards you. So by using the right-hand rule, your thumb points towards you, and then your fingers must be going to the left. So you should have something like this. So your thumb towards you, your fingers to the left, and then your palm will be facing downwards to the bottom of the page. So that means that this wire here will be deflected downwards towards the bottom of your screen or page. Okay, now moving on to part F. In this case, we're given the force. The force is being deflected downwards. We also are told the North and South poles are here, so we know that there are magnetic field lines that are going from north to south, so they're going to the right. So here in this example, we have the wire. It's like a cross-sectional view of the wire, and you're trying to find out whether the current goes in or out of the screen. So now moving your hand such that your fingers will be pointing to the right, and your palm faces down, you'll see that if your fingers are to the right, your palm is down, then your thumb must be pointing into the screen. And if it's going into the screen, that means our current is going to be shown like an X in here. So I is into page. Okay, now moving on to part G. In this case, we know that the force is up. We also know that the current has an X in it, which means the current is going in to the page. So you now need to orient your hand such that your thumb will be going in and your force will be going up. So that means you will have something like this. Your thumb going into the screen, your palm going upwards so that you have a force upwards, and then you'll notice that your fingers have to be pointing left. So our magnetic field is really to the left here, which means the right pole is on the north and the left pole of this horseshoe magnet is south. So we have a B field that is to the left. In part H, we have a force that is downwards, so downwards, and we have a current that is going out towards you. So I would show my thumb going towards you, my fingers to the left, it turns out, so that I have a force that is pointing down. So force down, current towards you, and our fingers would have to be pointing to the left. So I'll just show these field lines going to the left, and therefore the right pole is the north and the left pole is the south for this configuration to work. And that's the direction of the magnetic field. In our last example, in I, we know that the force is upwards. We know that there's a north and a south, so that means the field lines are going to the left, and we're asked to find the direction of the current. So orient your fingers to the left. Your palm is upwards, and what you'll notice is your hand will have to be pointing into the screen for you to have a force upwards and field to the left. And that means our force is going to be, or sorry, our current is going to be into the screen. So I is into page. And that's it for this example.